slides? All of you can see my slides? Very good. Now, so regarding slopes and deflection, first of all, a very few points that you must able to note it down, because some of you might be thinking, sir, sign convention is will be a very difficult for us to understand actually. But believe me, you need only the magnitude. You do not bother about the directions as well as sign convention for slopes and deflection. Only magnitude is important. Believe me, if you are writing any examination from now onwards, there will not be any problem regarding sign as well as what you say this directions, anti-clockwise or clockwise. Let me show one example. Things will be getting clarified after the discussion of the examples. Just wait, let me take the example. Okay. So here, my dear friend, if you just think of double integration method, suppose if you are thinking of using double integration method all the time, suppose you are feeling very easy and convenient to do the integration, then there is a drawback. What are the drawback? Suppose I am applying the load P at the free end of this cantilever beam. Double integration method, we can solve this problem. Double integration method, we can solve this problem. Double integration method, we cannot solve the problem. For this, knowing the method is not important. Applying and when to apply the method, that is very, very important, right? This conclusion, suppose you want to reach, you need to solve the textbook. You need to invest at least 20 days of your preparation. Then you will come to the conclusions, right? Now, so here the come the importance of the classes. So for this double integration method, cannot be used. Double integration method cannot be used. I mentioned one point. Very important formula is EI d square y by dx square. That is equal to what? M into xx. Suppose you are using this particular formula or with the minus sign. My define for integrating this mx tax, whatever the moment you are calculating at that particular cross section, that must be constant. If that gonna be vary, suppose you are taking this section AB and BC. In this section AB, the moment is what? Varying. In section BC, the moment is again varying. You cannot apply double integration method. For this, either you just apply moment area method, or you apply Castiglione's method, or you apply conjugate beam method, or you apply Macaulay's method. Please note down, very important. The similar concept with the go with the what? A very simple case that you will never imagine that simply supported beam. In fact, simply supported beam will also, you will also not able to solve by what? This method. Again, movement is what? Going to be changed. In this section, suppose you are taking from here to here. Suppose A, B, C, in between AB, moment is different. In between B and C, taking from the left hand support will be different again. Again, you cannot apply the double integration method. Please note down, very important. So it is suitable. It is suitable when equation of bending moment at a section remains constant throughout the length of the beam. Throughout the length of the beam. Very, very important. Please note down. Very, very important, guys. So whenever you just see the problem where the bending moment is varying, you will just ignore applying this double integration method like anything. You will be the first person who will ignore this particular method, and you will be at the top rank, believe me. So that's one of the very important things that we need to understand pros as well as cons of each and every method. Please note down. One more thing, one more doubt I will make sure that it will be clear for you. I know you might be having many doubts, but believe me, things will be clarified in just 5 minutes of time. Now, once it is done, let me know. Now, perfect. So yesterday there was a moment area method discussion was happening. Moment area method. And according to this, suppose there is a two section P and Q, and whatever the area was there, area under this curve will be directly giving me the slopes. Theta Q minus theta P. It is directly giving me the area of M by EI diagram. Area of M by EI diagram between P and Q. Whatever the suppose theta P is 0, and whatever the answer you are getting, whether it is positive or negative, just take the magnitude. Just take the magnitude because why I'm saying, suppose you are calculating the deflection, yq is equal to what? Suppose you are calculating the deflections, yq is equal to what? Yp plus theta q into theta p into q plus or minus delta q with respect to p. Suppose theta p is not 0. Suppose theta p is not 0. And suppose you are getting theta p. Suppose theta p is you are getting something minus WL square divided by 2A. Suppose put with the positive sign. Put the mod, and then you just calculate the whatever the deflection at point Q. That's it. Always take this particular formula when only magnitude will be there. That's it. And of course, here it will be plus minus depends on whether it is a simply supported beam or cantilever beam. Understanding? So only the sign convention will matter when you use double integration method. Apart from it, forget about the sign convention. Understand? Tell me, guys, are you getting my point or not? Check it out. Perfect. So yesterday we were discussing one point. There was a load that has been acting at a distance of 2L by 3. And suppose we need to find these deflection at point Q. Suppose at point P there is a load P is acting. At point Q there is a no load, and the deflection curve will be what? Something like this. The deflection curve is something like this. Something like this. Suppose the deflection curve is something like this, my dear friend. Suppose that. In this case, what will happen? In this case, what is gonna be happening is that suppose you need to calculate by Castiglione's theorem. There is a no load is acting at this particular point. What you do? Apply some imaginary load W. try to find the slopes and strain energy for PQ, PC plus strain energy of what? PQ. After finding the strain energy, suppose you want to calculate the deflection at point Q, what you do, differentiate strain energy, total strain energy with respect to W. After that, put W is equal to what? 0 in the final equation. After differentiating, put W equal to 0 in the final equation. And whatever the answer will be there, that is a directly answer for what? This one, deflection. That is what the casting limits method. So that is a very lengthy method that actually we were discussing yesterday, right? So we need to take the cross section over here. Again, we need to take the cross section over here, and that is very, very lengthy procedure. Understanding my point? So whenever the question will be coming, try to see the method which can be suitable for that problem to solve in a very, very given amount of time, right? All of your understanding? All of you understanding what I'm saying? Once it is done, let me know. Done? Note down principal stresses and strains. Note down principal stresses and strains. That is a very, very important thing. Principal stresses and strain. Note down whatever the things are there on the slides. Just note down whatever the things are there on the slides. Now, why we need this principal stress and strain when we have a lot of other stuff actually? When we have the other stuff, then why we need this particular principal stress and strain? Anybody know the answer for this question? When we have the formula for the stress, that is load by area, then why we need this particular concept of principal stress and strain? Anybody know the reason? Try to understand. Not knowing? Anybody understanding? 3D object. Okay. 3D object also we can solve by normal stress form also, right? Load by area. In the respective perpendicular direction, suppose load has been applied, and whatever the area, if I just divide it, I will be getting what is stress value for 3D component also. Then why we need this particular concept? The concept called principal stress and strain. Understand whatever I'm saying. Whatever the basic SOM equation, suppose for example, whatever the right now discussion will happen for next 10 minutes, that is going to be very, very important for interview, right? Because if you attend any interview, they will be asking you why we require the principal stresses and strain when we have normal stress and shear stress value. So for that, let me explain you. Suppose I am applying the load P. Suppose. Now tell me what is the normal stress and area is what? Suppose you can take the area as A. What is the normal stress? Can I say P by A? Check it out. Tell me guys. And what will be the shear stress? What will be the shear stress value? What will be the shear stress value? Tell me guys. What will be the shear stress? What will be the normal stress? So I'll be having two questions. The very first question is, what is the normal stress? On the cross section or on the plane on the plane, CD. On the plane CD, suppose. On the plane CD. What is the normal stress on the plane CD? Second question will be, what is a maximum normal stress? What is the maximum normal stress in the bar? This is my bar. Maybe cylindrical bar, maybe rectangular bar, we don't know. That depends on the question. Check it out and tell me. For this particular two questions, I'm having the question right now. What is the maximum normal stress on the plane CD? And what is the maximum normal stress in the bar? See, A will be, the answer for A question will be, sigma will be equal to what? P by area. Now, whether it is a maximum or not, that depends on the, understanding, right? That depends on the understanding. Let me ask you the third question. What is maximum shear stress? Maximum shear stress on the plane CD. And my fourth question will be, what is maximum shear stress in the bar? Tell me guys. The answer for question B will be 0 or non-zero. The answer for question D will be 0 or non-zero. Or answer for question C will be 0 or non-zero. One of the very important concepts. Tell me guys and let me know. Zero or non-zero. You can just mention B option non-zero or 0. C 0 non-zero. D 0 non-zero, so that I can rectify. So that I can know. You mentioned the option, you can mention the question number also, A, B, C, D among that. Forget about A because I mentioned that it's a non-zero because sigma will be equal to P by A. You can also say that first question asks, what is the maximum normal stress on the cross section CD? Whatever the cross section has been shown, that particular cross section, what is the maximum normal stress, or what is the maximum normal stress in the bar, whole bar? One of the very important concept, guys. See, always remember one thing. Always remember one thing. Stress is defined at one particular point, and at one particular point, there will not be only single plane CD. There will be infinite planes. There will be infinite planes, my dear friend, which is passing through this point. A lot of planes will be passing through that particular point at a one particular point, right? What is the maximum normal stress? That is the perfect answer for A. But if you just ask me what is the maximum normal stress in the bar, again, that is going to be same answer. I will be telling you why, but as of now, just note down that is the correct thing. What is the maximum shear stress on the plane CD? It's a zero value, right? Because on this plane, there is no force parallel to the cross section. Any force is there which is acting parallel to the cross section? Zero, right? There is no force that has been acting parallel to the cross section. Am I right or wrong? Tell me, guys. So whatever the answer is there, that is correct, right? Perfect. But if I'm asking you what is the maximum shear stress in the bar, and if you say that is zero, that is not correct. That is not equal to zero. On that cross section, if I say on the plane CD, the shear stress will be zero because there is no shear force. But in the bar, if you just ask me, the shear stress will not be zero. My dear friend, why? Because if we just take the bar something like this, suppose you are taking any plane, incline at a direction of theta. Suppose here there is a load P, here there's a load P. On this plane CD, let me show the plane. Focus, just focus. This is the plane CD. On this plane CD, there is no force. But what about this CE plane? On this CE plane, if you just resolve this component, one force will be acting like this also. Because if I just resolve it, so one force will be passing like this and another force will be passing like this. And that is going to be because of this component of the force, there will be shear force on this plane EC. And because of that, the shear stress will not be zero. So if somebody will ask you what is the maximum shear stress on the cross section when there is no shear force, it's a zero value. But in the whole bar, you cannot say. Understanding? All of you are getting my point? Now, this is the one statement. First of all, note on this thing, very, very important. Once it is done, let me know. I'll be framing one more way so that you will understand why you need the principal stress and strain. Right now, you got the development and understanding fundamental thing that, okay, what is actually happening, right? Because all things are matter because one definition is there, stress is defined at one point. Stress is defined as one point. At one point, a lot of planes are passing through. CE plane, right? So suppose this is CED plane, CE plane. CE plane will be something like this. This will be CD plane, right? Suppose, of course, that is a different part. This will be C dash D dash plane. Suppose this will be E dash and D dash plane. A lot of E double dash. A lot of planes are passing through this point P, or maybe some any point number one, right? And stress is defined at one particular point. So we need to see on all the planes whether shear stress is zero or not. If that is equal to zero, then we say that the maximum shear stress in whole bar will be zero. Otherwise, if any plane containing the shear stress value, we cannot say it's a 0, 1, right? Done, all of you? Is it done? All of you have noted down? Correct. Now you will enjoy somewhat more. Let me just give you one question. There is a cylindrical bar which is subjected to the torque, T, and one axial force P. Suppose this is 50 kilonewton and the torque value is what? 500 Newton meter. The length value might be given to you something L equal to 1 meter. The diameter will be given to you something, suppose that 50 mm. Suppose you will be given all the data for this cylindrical bar. They are asking the question, note on the question, maximum tensile stress and maximum shear stress induced in the bar right? Second question will be maximum axial stress. Of course, same thing only, normal stress or axial stress, and torsional shear stress. Torsional shear stress on the cross section of the bar. So these two questions I'm just giving you right now. Let me know the answer one by one. Zero or non-zero, that you need to tell me. Take your time, just think and just tell me. Now, try to understand my difference. Somebody will ask me, somebody will say, sir, maximum tensile stress will be, sir, P by area, that is P by pi by 4 d square. That will be the answer, sir. Okay, that will be the answer. Now, but that answer is correct for A or B, we don't know. Sir, what is the maximum torsional stress? 16T divided by pi dq. Sir, how this formula came? Because we have not seen the any torsional loading conditions. See, you know the torsion equation. If not, then we will cover the next chapter. T by J, that is equal to tau by R. T by J, that is equal to tau by R, that is equal to G theta by L. That is my torsional equation. This is my torsional equation. This is my torsional equation, my different, right? T by J, tau by R equal to G theta by L. Forget about this term. Forget about this particular term. Focus on this, the first two equations. T by J equal to tau by R. G is what? Polar moment of inertia. Polar moment of inertia. Tau is nothing but what? The shear stress. R is what? Radius, my different. So from here in this one, tau will be what? T into R by J. T into R. R is what? Diameter by 2. J is what? What is the polar moment of inertia for circular cross section? Polar moment of inertia, always remember, it's about the longitudinal axis. So IZZ will be IXX plus IYY. Suppose the cross section is what? Something like this. XXYY. Perpendicular to this plane will be what? Perpendicular to the plane of the paper will be ZX axis, right? And about ZZ, whatever the moment of inertia will be there, that I am calling what? J. And that is what? 2 into pi d power 4 by 64. So from here you will be calculating as something like this. Now once you know J value, you can substitute there pi d power 4 by 64. So you'll be calculating at what? 16T into 2 divided by what? Pi dq. Understanding all of you? How we got the equation for the maximum torsional shear stress? Check it out. All of you are understanding? Of course, we will cover this thing in the torsional loading condition also, but as of now, this is the situation right now. Sir, okay, maximum normal stress and this thing is calculated, but this is not the answer for A. These formulas are some formula, I agree, but these are valid when there is only one load that has been acting, that is P load. But right now, my dear friend, there is a twisting also. When there is a twisting, and this formula is valid when there is only twisting. But right now, both are acting at one particular point. When both are acting, my dear friend, that is not be your maximum tensile stress, that is not your maximum shear stress. At least for one plane, this plane. This will not be the maximum tensile stress, this will not be the maximum shear stress. For that, you need to select the plane because stress is defined at one particular point, and at one particular point, there's a lot of planes are there. Take any plane which is inclined at an angle theta, and try to derive the equation. For that derivation, my dear friend, we are learning the chapter called Principal Stress and Strain. Please note down. Very, very important. Because that plane we might look at where the maximum tensile stress can be acted, right? Understanding or not? All of you are understanding? Correct. So just note down. Now, what is the state of stress? What is the stress of stress at the point A? If I take the point A, what is the stress of stress? So the state of stress will be, for the point A will be, so sigma is acting, there is a no sigma y, but there is a torsional shear stress that has been generated. So there is a torsional shear stress because of this twisty movement has been generated, and that is I'm going to show something like this. That is what I'm going to show something like this. That is what the state of stress for the point A. No doubt. State of stress for point A. Now somebody will be asking me, sir, this is a tau and this is tau, but sir, why you can only represent like this also, right? You can only represent like this also, but why you need some complementary this thing above and below? Why you need that one? Because, tell me guys, because what? Because what? Couple balance. Understanding or not? See, this particular thing as well as this particular thing will make this body what? Under rotation. This thing and this thing will balance out and they will cancel out. There is no pulling and there is no pushing. Sorry. There is no pulling and there is no pushing by different. But this particular thing and this particular thing will try to rotate this body in a clockwise direction, and this body will not remain in the what? And that this particular body will not remain under what? Static equilibrium condition. I mentioned that starting of the SOM subject, there is some relationship between engineering mechanics and SOM. In SOM, whenever we draw the free body diagram, whenever just we define the state of stress of any point, we just say that that particular point is under static equilibrium condition by different. For maintaining that, we need to apply opposite direction so that this torque will also be cancelled out. So that this body will under what? Static equilibrium conditions. Now, note down, very important. This is called state of stress for the point A. That's a very, very important. So we will take one particular plane, define at an angle theta, and we will try to explore where I'm going to get the maximum normal stress. Where I can get the maximum normal stress. That's a very, very important thing, my dear friend. Now, once it is done, let me know. The second question is whatever the question you are showing me right now. What is the maximum axial stress and torsional shear stress on the cross section of the bar? This question can be calculated once you have only P, once you have only T. If both are acting at a time, again we have to use principal stress and strain. That we will understand. Do not worry. Once we have any question in front of us, the things will be clarified. Do not worry. Now, after noting down, please let me know. Done, all of you? Once it is done, let me know. Done, right? Correct. Note down principal planes and principal stresses. I told you at one particular point there are a lot of planes are there. Lot of planes are there. Lot of planes are there. Suppose any member is subjected to combined loading conditions. Normal stress as well as shear stress. Both are acting for this component. So there is nobody can challenge me, sir. This plane, AB plane, is containing use what? Pure axial stress. No, no, no. Plane AB will be containing shear stress also, and as well as what? Normal stress. But if you remember, we need to find a plane. We need to find a plane where there will not be any shear stress. Only normal stress will be there. That particular plane we call principal plane, no doubt. It has been observed that at any point in a strained material, there are three planes. There are three planes. Those three planes will be mutually perpendicular to each other, which carries the direct stresses only. No shear stress. Very important. The planes which carries no shear stress is called as principal planes. And whatever the stress value will be acting on that plane will be called as principal stress. If I'll be asking you this plane, A dash, B dash, is it principal plane or non-principal plane? Or it's a normal plane? Whether A dash, B dash is a principal plane or non-principal plane? Verify it. All of you, please verify it. How can you say? See, again, it is carrying the normal stress as well as shear stress because of the twisting movement. Then how can you say that it's a principal plane? Perfect. It's a non-principal plane. Remember, it's a non-principal plane. No doubt. No doubt. Very, very important. In searching of those planes at an angle theta from the vertical or horizontal, we will define one formula. We will try to derivate one particular formula. With the help of that, we can find at any plane any value of the stress, right? That's the reason we are studying what principal stresses and strain. One more reason is there why we are focusing on this particular chapter. Try to remember. Whatever the basic SOM equations are there. Sir, what is the meaning of basic SOM equations? Sigma and tau. Sigma is what? P by area. Tau is what? 16T divided by pi dq for solid shaft. Of course, for hollow shaft, the formula will be different. Okay, that is different matter. Now, the basic SOM equation gives the values of sigma and tau on the cross section. At a particular cross section, but stresses is defined at one particular point. At one particular point, there's an infinite planes are there. So there will be infinite sigma and an infinite tau value will be there. Among all those infinite values of sigma and tau, we need to just find maximum normal stress, maximum sigma, maximum tau value. Now, why? Why we need to find the maximum sigma value? Why we need to find the maximum tau value? My dear friend, you know that ductile materials are very, very weak in shear. All of you are understanding brittle material and ductile material? Tell me, guys. Any ideas, sort of ideas you have about the brittle material and ductile material? Shall I discuss about this? Check it out. If you just take the ductile material, they are very, very weak in, shear loading. Weak in shear loading. That means they cannot able to resist more amount of shear load, right? It will fail. What's the problem with the brittle material? You cannot apply the large amount of tensile load. Very, very weak in tensile load. Now try to understand. This is my ductile material. Sorry. This is what might have ductile material. This is what might have brittle material. Ductile materials are very, very weak in shear. So that's the reason we are finding maximum shear stress value. Brittle materials are very, very weak in tensile. That's why we are finding maximum normal stress in such a way that we can design for maximum normal stress and maximum shear stress. Please note down, very important. Again, some of you might be asking, sir, why? Sir, why? Try to understand. If you design your material for 30 megapascal, one component, and if you're designing one component for 80 megapascal, in which component you require the larger diameter? Suppose cylindrical bar is there subjected to normal stress or axial stress. In one maximum to maximum, you can apply the load condition in such a way that stress value, maximum stress value can be 30 megapascal. And in second component, it is 80 megapascal. Which one will require larger amount of material? That means larger diameter. Let me know. Just think and tell me. Being an engineer point of view, just think and tell me and let me know. Just note down, I will be coming back in 2 minutes. Tell me guys, in which case you will be required the larger amount of diameter? Yes, nobody's answering me. What happens, guys? See, 30 megapascal means the load value will be lesser one. 80 megapascal will be what? Load value will be higher one. When the load is higher, 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 you need to increase the area also so that the sigma value will be always what? In the limiting condition. Otherwise, when the load is keep on increasing, sigma value will keep on increasing and area suppose fixed. Suppose you are making the same area for both the component, my dear friend. The moment you reach beyond 30 megapascal load, your material will start yielding. Your material will fail. Right? For that reason, whether your component is what? Sigma normal on the cross section, you are 30 megapascal. Suppose AD is what? Sigma maximum in the whole bar. When there is a combined twisting and axial loading conditions has been given to you, suppose you are finding with the help of some formula, that formula I will be giving to you. No, do not worry about those things. Suppose with the help of sigma maximum that you are calculating from the principal stress chapter, 80 megapascal is coming. From the SOM equation, you are calculating 30 megapascal. That means you are at the wrong path. That's the reason we are finding that for the brittle material, which is the most suitable diameter, that will be decided based on the what? Maximum normal stress that can be calculated, 80 megapascal. Ductile material, that can be calculated by what? Tau maximum. Because suppose any ductile material if you take, and suppose you are applying the loading condition like this, and what you will say, sir, according to SOM will say that, SOM equation will say that sigma will be coming sir P by A. And that means you keep on applying sigma, it will never fail because tau value is 0. But you are wrong. You are calculating at this cross section only. Maybe at some other cross section, tau may be acting. Who knows? Tau may be acting, my dear friend, at that particular angle, plane. In that case, we need to find maximum tau. So that, see, if you just think tau will be 0, if I put the diameter, suppose 1 mm only, it will able to survive. But who knows, on some other plane, the tau value will be suppose 5 megapascal. Will it able to survive that particular diameter? If you just think on the basis of tau equal to 0, just tell me. Somebody said to you, some customer will be coming to you, he'll be saying that, sir, I'm having one cylindrical bar, I'm applying the tensile loading condition, and I'm having the ductile material. You'll be very happy. And what you will say, just go, my dear friend, and enjoy like anything that component, because that component will never fail, because tau value will be 0 in that case. And suppose that customer will be gone, and suppose he has just taken the component and he just applied some application, and suddenly he got to know that particular diameter is not sufficient and that is suddenly failed, then what will happen? Again, he will come in the next day, he'll be come back to your office and he will say, just throw that particular component onto your what? Whatever the suitable position will be there, whatever the suitable places will be there, he'll be just throwing that particular component. And he will say that what component you have just given to me, on the what basis you have designed this component. And simply he will just asking you whether you know about the principal stress and strain or not. If you say no, he'll be just there itself, the deal will be cancelled out. Understanding or not? Because you have designed this component based on this cross section on the plane CD. Because at one particular point, there's a lot of planes are there on which the tau value will not be 0. There may be some tau. So in actual condition, when the load has been applied on that particular plane, suppose tau is there, that diameter 1 mm will not be sufficient to survive that particular stress value. But suppose you have designed for this 5 megapascal and you just give the diameter to be 10 mm. Whatever the loading condition the customer will apply, your material will never fail just because of the maximum stress value conditions. In shearing, it will never fail. Understanding? Tell me, guys, whether the purpose has been fulfilled or not. Why we are studying the principal stress and strain? Forget about the syllabus here. Again, I'm telling you, do not focus too much on that. Just think why we are studying, because that is very, very important thing. Now, once it is done, then let me know. If you just want to note down, you are welcome to note down. After that, we have only the formulas. After that, we are having only the formulas and sign conventions. Here, the sign convention will matter. Here, the sign convention will matter, my dear friend. There's no doubt about it. Now, just note down. Suppose this is the state of stress of any component, sigma xx, sigma yy, sorry, sigma xx, sigma yy, and there's some kind of shared stress that is also going to be acting. Tau s or tau xy, because that has been acting in the xy plane. So I can call this to be tau xy, tau xy. And I'm taking at one particular angle. Suppose this particular element has been rotated. Suppose this particular element has been rotated by the angle theta in the anti-clockwise direction. Again, listen what I'm saying. There is a two types of question. There's a two types of question that can be asked. A very first type of question is that rotate this particularly element, rotate this element by angle theta with respect to horizontal in anti-clockwise direction. That is the very first type of question. Rotate this angle by angle theta, rotate this element by angle theta with respect to horizontal in anti-clockwise direction, and find the sigma and theta and tau s theta on that plane. On which plane? The plane which has been rotated by angle theta in the anti-clockwise direction. Whether you understood this problem? Type 1. Tell me, guys. Whether you understood the type 1 problem or not. Take your time and let me know. Rotate this element by an angle theta with respect to horizontal in anti-clockwise direction and find sigma n and tau s theta on that plane which you have been rotated. Tell me, guys, and let me know. Very, very important. Very, very important. Now, try to understand. Try to understand what I'm saying. Rotating this element, my dear friend. This is y, initially y axis, initially x axis. I'm rotating this element. I am rotating this element by the angle theta. By the angle theta, I have been rotated this particular element, and I'm asking you what will be the values of normal stress and shear stress at a particular element, at a particular plane which has been rotated by the angle theta. Now, just think of this question and let me know whether you have understood this particular rotation or not. See, from the horizontal axis, I have been rotated this element by anti-clockwise. Check it out. So this will be my xx originally, and this was my originally yy axis. Right now, which I'm showing you, this is x dash, and this is what? Y dash. Check it out. Clear or not? Let me know. Whether it is clear? All of you, whether it's clear or not? My dear friend, they are asking you a beautiful problem. The plane which you have been rotated by the angle theta, the plane which you have been rotated by the angle theta with respect to horizontal direction, with respect to what? Horizontal direction. On that plane, you need to find sigma n xx. You need to find what is the tau that has been acting. What will be the sigma yy? What is the sigma y dash? That you need to calculate. Please note down, very important. This thing, my dear friend, you need to calculate. You can also call sigma n theta. Note down, guys, very, very important. Or simply you can just note down sigma x dash. Or simply you can note down sigma x dash. In many of the textbook, they are writing many things. I have written all the things. Note down, very important. Of course, this side also will also be there, because to maintain the static equilibrium conditions, these are the things that is going to be required. As of now, on this plane, the plane which I am showing you right now, suppose this is the plane AB. This is the plane AB. This plane has been rotated by the angle theta. This plane has been rotated by the angle theta. Then sigma x dash, whatever the sigma x will be there, that has been converted to sigma x dash. There will no longer sigma xx will be acting on that particular plane. Are you agree with me or not? Let me know, guys. Whatever the plane AB is there, suppose I am showing you with the same AB plane right now also. But right now in AB plane, normal to the AB plane, whatever the sigma x dash will be there, sigma x dash will not be equal to sigma x. Right? That's one sort of very, very important thing that you must be able to understand. Right? Now, just forgive me. I'm just changing the direction of tau because of some purpose. I will tell you what is the purpose. Just have some patience. Let me change the direction. You will enjoy like anything, my dear friend. There is a guaranteed. Now, on the plane AB, for the plane AB, suppose we want to calculate sigma n theta and tau s theta that has been acting. What is the formula? Just note on the formula. Sigma n theta will be sigma xx plus sigma yy by 2. Sigma xx, just wait, please. Just wait. Yeah. Sigma xx minus sigma yy by 2 into cos 2 theta plus tau xy sine 2 theta. Tau s theta will be sigma xx minus sigma yy by 2 sine 2 theta minus tau xy cos 2 theta. Note down, guys. Very, very important. In fact, not for the plane AB, you can just find this formula for any plane. For any plane, if you just want to find the normal stress on that plane and the shear stress on that plane, which is just inclined by the angle theta, with the help of this formula, you can able to determine. These equations are called as transformation equations. This equation is called as transformations equations. Very, very important. Transformation equation. Sir, why you are giving the name transformation equation? Because, my dear friend, initially the coordinates initially what are the coordinate axes? X and Y. Now the coordinate has been changed to X dash and Y dash. So there is a shift happening from XY axis to what? X dash and Y dash. That's why we are transforming from X to X dash and Y to Y dash. That's why the name has been given transformation equation. Note down, guys, very important. Just follow my thing, whichever I'm saying to you. Do not follow any textbook for this case for principal stress and strain. That is my more than 100% challenge is there. All the problem you will be able to solve all the problem till date. Whatever the gate examination that they are asking, you will be able to solve that particular problems, all the problems. Now, once it is done, let me know. I told you only type 1 problem. Once the element has been rotated by the angle theta, then what will be the normal stress on that plane? What will be the shear stress? Plane, remember this is a plane. This is called plane. Right? Some of you might be thinking, sir, this is the element. Now why we have rotated by the 90 degree, that means this is a plane. No, guys. When we have rotated means what? This particular plane has been rotated by what? Angle theta, by the angle theta. That means what? This axis is what? Perpendicular to this plane, right? Understanding or not? All of you. Now, all of it done? All of it done? But there is some conditions. Some conditions, guys. What are the conditions? What are the conditions? To use this two equations, there is a condition that is sign conventions. There is some conditions that has been imposed. That is nothing but sign convention. Note down sign conventions. If we want to use my equation means what? This equation and this equation. You need to follow my sign convention. Sign convention. Note down the sign conventions. If it is acting like this, then take sigma xx to be positive. When this is going to be acting like this, then take sigma yy to be what? Positive. When this element is being subjected to like this, then you take it positive. Tau xy will be positive. When this is going to be acting like this, please take it out this to be negative. Very, very important, guys. Very important. And one more thing. Suppose you have rotated this element by the angle, suppose theta in the anti-clockwise direction. Suppose you have rotated this plane by the angle theta. So theta will be called as positive. Positive. Either you calculate from this horizontal, or you can just calculate, my dear friends, with the vertical also, with the vertical. Because see, once you have been rotated this element, once you have been rotated this element by the 90 degree, suppose, sorry, theta degree, then what will be this particular angle? What will be this angle? What will be this particular angle? This angle. Theta or not? Theta or not? Check it out. This is theta. This will be total angle is what? 90. I'm making complicated. Just wait. Just wait. The angle which I'm showing you right now, that will also be what? Theta. This plane AB is making an angle theta. This plane AB is making an angle theta with respect to horizontal, suppose. That means like this. This is what we have. This thing. This is the vertical. This is the vertical. So something like this I want to show. So this is theta. This is theta. Then what about this one? This is 90. What about this one? 90 minus theta. Then what about this one? Theta, right? Then only the angle will become what? 180 degree. Understanding or not? All of your understanding? Perfect. So just note down. Or they can ask you the type 2 problem as they will give some angle. They will give the stress of they will give the state of element, something like this, and they will be giving you one plane with an angle theta in the anti-clockwise direction. Suppose they will be giving you sigma yy value, sigma xx value, here also sigma xx, here also sigma yy, and they will be asking you sigma and theta and tau s theta for the plane AB. For the plane AB, what is the sigma and theta? And for this plane, what is the tau s theta? That's a very, very important thing, guys. Please note down. Type 2 problem. Type 2 problem. Suppose tau s theta is come out to be what? Positive. That means your plane angle will be something like this. It is going to make the rotation. On this one, it is going to be something like this. That means if you just draw the hypothetical one more plane to join together, this will make the contribute the this rotation to be what? Anti-clockwise. Right? Suppose at any plane which is just inclined to angle theta, and suppose on that plane CD, you are calculating and you have got the value of tau s theta to be negative, that means what? It is clockwise. Understanding or not? Of course, we need to show only one arrow, which is just acting on the CD plane, not the other side arrow, but to make you understand whether it is a clockwise or anti-clockwise, you need to remember like that, right? That means anti-clockwise, they should be able to make this rotation, and here they should make rotation as what? Clockwise. Understanding? All of your understanding? No, no, guys, that's it. That is more than sufficient. You will be able to solve 1,000 problems. That is my guarantee. You will never stuck. Now, done all of you? Once it is done, let me know. Yes. Done all of you guys? Is it done? Done, guys, all of you? Perfect, perfect. We will try to solve, but before that, let me just we will try to explore a few more points about this concept now. So there's a type 2 problem which I told you. That means the problem can be asked in two ways, either type 1 ways or type 2 ways. That is the one thing that I want to show. Not only principal stress and strain, how to calculate this thing. Principal stress and strain. Principal planes. Principal planes. This thing we want to calculate. Suppose this is a very, very important, guys. Try to understand each and everything very carefully, very calmly. Try to understand. Suppose you have taken the plane at an angle theta in order to hope theta star is in the but one hope is there where you will find the maximum normal stress. There will not be any shear stress. There will not be any shear stress on that plane. That means whatever the tau s theta formula is there, that means sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta. If I just say this to be 0, so whatever the theta I will be calculating, can I say this is to be theta star? Can I say this to be theta star? Where the tau s theta on that plane will be 0. Can I say on that plane, if tau s will be 0, that particular plane will be principal plane. And on that particular plane, whatever the normal stress is going to be acting, that will be principal stress. Check it out. All of you, please check it out. And let me know. Let me know, guys, whether you're understanding or not. Perfect, perfect, perfect. Now, so yeah. So here, from here, what we can calculate, sigma x minus sigma y by 2 sine 2 theta, that is equal to tau xy cos 2 theta. So from here, what is the tan 2 theta? 2 tau xy divided by what? Sigma x minus sigma y. Please note down. So from here, whatever the theta will be calculating, one is what? Theta 1 star, other is what? Theta 2 star. Very, very important, guys. Very, very important. Two principal planes you will be calculating. One is this principal plane, and one will be perpendicular to this one, with the 90-degree, right? So there will be two planes you are calculating, right? One is you are calculating sigma 1, and in another plane you are calculating sigma 2. One is called major principal stress and another is called minor principal stress. No, guys, very important. This theta 1 star and theta 2 star, you put into the formulas, this one. Whatever the formula I told you, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sine 2 theta. In this formula, try to put theta will be theta 1 star and try to put theta will be theta 2 star. You will be calculated as sigma 1 and sigma 2 comfortably, right? That is the procedure. That is the one way of calculation of the principal stress and strain. I will be telling you second formula also. I will be telling you second formula also. First of all, note down these things, then we will discuss. Very, very important, guys. Very, very important. And what is the relationship between theta 1 and theta 2 star? Theta 2 star will be theta 1 star plus 90-degree. Both the planes will be at a 90-degree with each other. Both the planes will be at an angle 90-degree with each other, my dear friend. Now, once it is done, let me know. Once it is done, let me know. Perfect. Perfect. Note down the second formula for calculation of principal stress and strain. The very first method is that either you just put theta 1 star to this particular formula and calculate sigma 1, theta 2 formula in this one, calculate sigma 2. That is the one way. Second formula, sigma 1 and 2 will be equal to sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Very, very important, guys. Please note down. That means sigma 1 will be sigma x plus sigma y by 2 plus formula will be for sigma 1 because sigma 1 will be greater than sigma 2. This is called major principal stress. This is called minor principal stress. Sigma x minus sigma y by 2 whole square plus tau xy square. Sigma 2 will be same formula, put with the minus sign. Same formula is there. Very, very important, guys. No. And what is the correlation? Sigma 1 plus sigma 2 plus sigma 3 will be equal to sigma x plus sigma y plus sigma z. Note on this formula also will be very, very important. For 2D, you can write sigma 1 plus sigma 2 will be sigma x plus sigma y. That you can verify with the formula. When you just add these two formulas, you will be left with the only sigma x plus sigma y. Note on, guys, very important. Very, very important. Once it is done, let me know. Once it is done, let me know. Done. We can see one problem. Beautiful problem. I believe that you will be able to solve this problem. Question. A machine component is there. Machine component is something like this. And on that machine element, I'm taking one element A. I'm taking one element A. I'm going to zoom this element. When I'm going to zoom this element, I'll be left with a stress element, something like this. On that particular element, on the machine element, this is the machine component. This is a very big machine component. I'm taking one small element A. Small element A. And I'm going to apply it. I'm just seeing that and I'm getting shocked when the loading condition has been given as 50 megapascal in the x direction. When the loading condition has been given something like this. When the loading condition has been given 70 megapascal like this. And when there is a shear stress will be acting something like this. This is 30 megapascal. One arrow will be given, other arrow you can draw based on the static equilibrium conditions. They will be asking you one question on this particular plane. Let me remove the, because it is not looking good. Remember that it is for the element A only, Now, suppose this particular plane is there, plane CD plane is there, which is inclined at an angle theta with respect to clockwise direction from the, this vertical plane. They are asking what is sigma and tau at oblique plane CD. That is a very simple question they are asking. No difficulty should be there. Two ways. This problem can be seen in two types. The type 1, we can say that this particular element has been rotated. This particular element has been rotated by the angle theta with respect to horizontal in clockwise direction. One way. That is going to be one way. Second way, the type 2 ways, you can see that I told you one particular plane will be given to you and they will be asking you sigma and tau on that oblique plane. Either you look from the type 1 problem or you look at the type 2 problem. The answer must be same. Let me just give the same problem in the type 1 fashion. Type 1, how? Just look at very carefully. A lot of confusions are there. That's why I'm stretching too much, believe me. Now, this is 70 will be there. With respect to horizontal, my dear friend, with respect to horizontal, I am just rotating. Sorry. With respect to horizontal, original x-axis will be there. With respect to that, I'm just rotating this element with respect to what? This element I'm going to rotating with respect to theta in the clockwise direction, like this. Look at very carefully. If you understand this one, you will be able to solve GATE 2016, GATE 2022, GATE 2019, GATE 2020 also. So 4-year problem you will be able to solve within fraction of a second. Otherwise, you need to spend your whole 6-month duration for this only. Now, why 6 months? Because again you revise, again you forget. If you just read from other sources, no clarity about the anything. Now, what I'm saying, this particular plane is there, and suppose this is the one more plane is there. There's the one more plane, something like this. This is what my new x dash. This is what my new x dash. Suppose that, right? Before it was something like this. Now it is something like this. And on this plane, I need to find the sigma and tau. Check it out. The plane which has been rotated by theta in the clockwise direction. Check it out, guys. Either you are getting the same problem or not. Clockwise. Either you say like this or you say like this. Both the problems are same or not. Check it out. On this plane, which has been rotated by the angle theta with respect to horizontal, that we need to find. Initially, it was something like this. But now when it is rotated, so this will become y dash. This will become x dash. Check it out. Getting the clarity about the problem. Check it out. Either the problem can be given like this, type 2 ways, or the problem can be given like this. Check it out, guys. Both are same meaning. Check it out. Please tell me, guys, whether you are understanding or not. Because things must be understood, not only seeing the answer, that's it. The things will not be enough. Right? Now, once the things will be given to you, type 1, type 2 problems are clear to you. It's a matter of only 5 seconds to solve this problem, because you know sigma x plus 50. You know sigma y minus 70. Follow my sign convention. Follow my sign convention. You will never gonna get the wrong answer. Theta. The theta value, suppose that 30 degree. This is what? 30 degree. Positive or negative? In my notation, it was anti-clockwise. In my notation, it was anti-clockwise. But right now, whatever the figure it is showing to you, it's showing that it's a clockwise in both the directions. In both the type 2, in the type 1 as well as in the type 1 problem or type 2 problem, it is what? Clockwise. It is -1. Are you getting my point? All of you are getting my point or not? Tell me, guys, all of you are understanding or not? By design convention. Perfect. Now, once you understand this thing, you can calculate sigma and theta. What is sigma and theta, guys? You know that formula: sigma x plus sigma y by 2 plus sigma x minus sigma by 2 whole bracket cos 2 theta plus tau xy sine 2 theta. Put the value, get the answer. Put the value, get the answer, and tell me sigma and theta value. Tell me sigma and theta value, guys, very carefully. This is going to be sigma and theta. This will be called as sigma x dash. This is what we call the value. Sigma and theta. This is called sigma x dash. Check it out and let me know the answer. All of you. Yes. Done, all of you? Sigma and theta minus 5.98. Are you getting minus 5.98? Now, what about tau s theta? What about tau s theta? Sigma x minus sigma y by 2 whole bracket sine 2 theta minus tau xy cos 2 theta. From here, just calculate tau s theta. You will be calculated as 66 point, minus 66.96 megapascal. Check it out. Please check the answer and let me know the correct answer for this one. Please check it out, all of you. All of you, please check it out. All of you, please check it out. Suppose tau s theta I'm getting negative, that means what? What will be the directions? What will be the direction of tau? Like this. Understanding? So here in this case, it will be like this. It will be like this and it will be like this. All of you are understanding or not? Check it out, guys. All of you, please check it out. Here, sigma x is coming to be negative. That means the direction must be opposite. All of you getting my point? Check it out. Sign conventions. That sign convention, whatever we are following, that will be applicable for transform element also. From the straight element to transform element which has been rotated by the theta angle in the clockwise direction. Check it out, guys. Whether you are understanding or not, I don't know. Please check it out. Please match the answers. Correct? Done, all of you? So is it done, all of you? Correct. Correct. Now try to solve this one. Have some patience. Take your time and let me know the answers. The state of stress at a point has been shown below. Theta represents the principal plane corresponding to sigma 1 and sigma 2. The values of theta, sigma 1 and sigma 2, they are asking simply. They are subjected to tau, tau, tau. That means tau xy is positive tau or negative tau? According to our sign convention. Positive tau or negative tau? Positive tau or negative tau? All of you, please check it out. All of you, please check it out. Perfect. Perfect. Now, what will be the tan theta? What is the tan 2 theta? 2 tau xy divided by sigma x minus sigma y. In this element, there is no sigma x. There is no sigma y. So, my dear friend, it is what? 1 upon 0, infinite. What is the theta 1 star? What is the theta 1 star, guys? Check it out. Can I say it should be 90 degree? What will be the theta 2 star? 2 theta 1 and 2 theta 2 star. 180 plus 270 minus 90. Or you can say 270 plus 90. What are the two values of the tan theta value? When it can be positive. When is what? 180 plus 2 theta. That is also sine, right? So that is what? 270 degree. So 1 theta 1 star will be what? 45 degree. And another theta 2 star will be what? 135 degree. Check it out, guys. All of you are understanding or not? It's a pure and pure mathematics. Perfect. Perfect. Now they are asking what are the principal stress and strain. That's a matter of concern. Either you can just calculate by putting sigma and theta. That theta 1 is charge is 45 degree, but that is a very tedious job. We are not going to do that. Simply we are going to use the formula sigma 1 and 2. That is sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. But here this thing is 0. This thing is 0. So what we can say sigma 1 and 2 will be plus minus tau. Sigma will be tau. Sigma 2 will be minus tau. What will be the answer? C, right? Check it out, all of you. All of you, please check it out. One of the very, very important concepts that you can ever imagine about this principal stress and strain. Is it done, all of you? Perfect. Perfect. Now, try to solve this one and let me know the answer. All of you, please try it. A rectangular plate in a plane stress condition is subjected to normal stress sigma x and sigma y, tau xy. They are asking what is the ratio of the magnitude. Remember, they are asking magnitude. Do not bother about the sign of sigma 1 and sigma 2, whether it's a positive or negative, right? Now, let me ask you one question. Suppose sigma 1 is minus 200 megapascal and sigma 2 is plus 100 megapascal. Now, tell me what are the major principal stress and minor principal stress? If I'll be asking you major principal stress, what is the value? 200 or 100? And if I'll asking you minor principal stress, tell me, guys. Yes, major is 200, minor is 100. See only magnitude. Do not see the directions, right? Do not see the particular, the signs. That is a very, very important. Because mathematically, minus 200 is lesser than 100, but you do not think like that. You always think like a positive quantity. Suppose they are asking what are the major and what are the minor, because people do mistake in these particular areas. Coming to this principal stress and strain chapter, right? So note down, once it is done, let me know. Before that, let me know the answer also. Let me know quickly so that we can discuss about the Mohr circle also. You can take a little bit idea about the Mohr circle. That is one of the important concept actually. All the problem that you are saying is analytical method. Graphical method is what? Mohr circle. While finding the, see, whatever the loading condition has been given to you, that is called as complex loading condition. What is the meaning of complex loading condition? When normal stress, shear stress, both are acting, right? That is called complex state of stress. For complex state of stress, suppose you are using analytical method, that is what we have seen as of now. Somebody will be asking you, try to solve the complex state of stress and try to find the maximum principal stress and normal stress or shear stress by using graphical method, then there is a Mohr circle. Now let me know once it is finished. Again, we have the sign convention for Mohr circle. I told you in the SOM many sign conventions are there, but in only one chapter you need to ignore the sign convention is what? The sign convention is slopes and deflection. That's it. Apart from it, in all other chapters, whatever the sign convention will be there, that you need to follow thoroughly. See, shear force bending moment diagram. All of you are getting D answer. Let me know. If both of you are getting the same answer, then it's correct. Both of you are getting the same answer, D. It's a very simple. Use this formula sigma 1 and 2, sigma x plus sigma y by 2 plus minus so by using this formula, you will be calculated sigma 1 and 2. Correct. D will be correct then. If you are getting D, then it will be correct. Now, done all of you? All of you have noted down? Perfect. Now, so we will discuss about the, little bit about the Mohr circle. Just note down Mohr circle. It's a graphical representation of complex state of stress the graphical representation of complex state of stress is called as Mohr circle. Very, very important, guys. Now, try to just have some patience. X-axis we are going to show sigma, and on y-axis we are going to say tau, right? So, normal stress on any oblique plane will be equal to x coordinate of corresponding point on the Mohr circle. The shear stress on any oblique plane will be y coordinate of corresponding point on the Mohr circle. Note down. That means simply x-axis will represent normal stress, y-axis will represent tau. I will show you by example. Do not worry at all. Before that, note down the sign convention that is mandatory with respect to strength of material, subject concern. Once it is done, let me know. Done, all of you? Perfect. Perfect. Very good. Suppose state of stress, state of stress for any element has been given. Now, some of you might be thinking, sir, what is the meaning of state of stress? See, cantilever beam is there, which is subjected to this stress as well as twisting, suppose bending stress like this. Both are acting. Suppose P is acting, bending stress is also acting. Now tell me, which is the critical point? On above fiber or lower fiber? any point on the upper fiber or any point on the lower fiber, which is critical one. Because of this, my dear friend, there is a normal tensile stress will be developed. Because of the bending on upper fiber, there is a tensile stress, and lower there is a compressive stress. Overall, tensile will add it, and upper fiber will be what? Critical points. Suppose I'm taking this critical point P and I'm drawing this particular state of stress. Now you got the meaning? Now you got the meaning of critical state of stress? Because we need to design in any material with respect to critical point, not with respect to normal point. Because if critical point is not failing, the normal point will never gonna fail. Suppose I'm defining for P, what will be the state of stress? So sigma tensile, sigma x because of the axial condition, plus sigma bending will also be acting. Sigma x plus sigma bending. Overall, can I say sigma is acting and here also sigma is acting? Check it out. Perfect. So that is what the critical state of stress. Now come back to the sign conventions. Sign convention for Mohr circle. So in this same chapter, we have the two sign convention. One is for analytical method and second one is for what? Mohr circle. No doubt. If it is something like this, I'll be taking positive sigma x. If it is acting like this, I will be taking positive sigma y. Suppose if it is acting like this, I will be taking tau to be what? Tau xy to be positive. When it is acting like this, I will be taking as negative. No, guys, very, very important. Very, very important, guys. Highly important. These are the things that will be, fundamentally you should be correct for sign conventions. One more is there. Just wait. Correct. When it is like this, it is positive. Or when it is like this, means anticlockwise will be negative. Slightly different from what the sign convention you follow for this, series is for analytical method, right? Very important. There anticlockwise was positive, but here anticlockwise will be negative. That's a very small, difference. You can say that. Now, once we got the things, we can see the numerical. Once we see the numerical, things will become clear. Done, all of you? See the example. Directly, we can see the question also. A state of stress is given as sigma, sigma by 2, sigma, sigma by 2. Draw the Mohr circle for this stress of stress element A. Draw the Mohr circle for element A. That is what the question mark. That's a very simple. First of all, define the coordinate. Okay. So I'll be just not telling you the value, this elements A. I will be just telling you the element just to be what? C. Because some reason is there. Coordinate A. What is the coordinate A? If I say coordinate means what? Sigma and tau, both will be coming. What is the coordinate? Sigma and 0. What is the coordinate B? What is the coordinate B? What is the coordinate B? For this plane, we define one coordinate. For this plane, we'll define coordinate B. Can I say sigma by 2, 0? Check it out. Plus sigma by 2, 0. Plus sigma 0. Because there's a no tau. Perfect. try to follow the procedure which I am telling you right now, my dear friend. So this is sigma, this is top. A is what? Sigma 0. It will be coming over here. B is what? Sigma by 2, exactly half, my dear friend. Sigma by 2 comma 0. So you got the 2 point. That's a perfect. That's a perfect. Take half of this point. Take half of this point. Take the whatever the elements you have, or maybe some instrument you have for drawing the circle. Draw the circle by taking the radius. Draw the circle like this. Draw the circle like this. This is the point A. This is the point A. This will be your point A, right? Which is sigma and 0, right? This is going to be Mohr circle for this particular case. All of you understanding? All of you understanding? Now, there is a, not only we are drawing the Mohr circle, we are finding so many things, so many things. Whatever the things we are finding by the analytical method, we are finding by Mohr circle also. Now, what is the major principal stress? If somebody will ask you, sigma 1 value. That is very simple. First of all, find the center one. What will be the center one? What will be the center one? There is a shortcut to calculate the center, but just note down sigma x plus sigma y by 2 comma 0, because center will always lies on the x-axis, right? The center will always lies on the x-axis, that is sigma x plus sigma y by 2 comma 0. That will be center. That is going to be center, my dear friend. What is the center value? What is the center value? See, first of all, find the distance. What is the diameter of the circle? What is the diameter of the circle? What is the diameter of the circle? The distance between A and B, right? Under root of sigma minus sigma by 2 whole square plus 0 minus 0 whole square. How to find the length of the line? We have the two coordinates, A and B. Suppose you want to find the length, whatever the coordinates are there, you try to subtract it and take the under root of that. Yes or no, guys? That is what you are finding or not? Please check it out. Perfect. Perfect. Now, sigma minus sigma by 2 whole square. From there, what you can calculate? Sigma by 2. That is what the diameter of the circle, you got it. But if I'll ask you the radius of the circle, then what will be the answer? That is the diameter of the circle, that is AB distance, you got it. And that will become what? Diameter of the circle. But what will be the radius of the circle? Sigma by 4. So what is the major principal stress? Major principal stress will be this one. From 0, 0 till the point A, that is a major principal stress. Now let me draw once again, because here the diagram is little bit hodgepodge. So let me just make you very clear. Because if diagram is clear, all the things we can just answer within the fraction of second. Whatever the things you are doing with the analytical one, you can just get you can just get it by what? Simply by drawing the Mohr circle. Now assume this is the Mohr circle, my dear friend. So this is the point B, this is the point A. From the center to the point A, this is called reference plane. Each and every radial line is a plane. Note down. Each radial line is plane in the Mohr circle. Each radial line is a plane in the Mohr circle. That is the one thing. So CA is what? Reference line. Reference line. Understanding my point or not? All the angle will be measured with respect to C only. All the angle will be measured with respect to C only. Right? Now, what is the major stress, my dear friend? Major principal stress. If I'll be asking you what is the major principal stress, what you will answer? From here to here. That means OC plus radius. OC plus radius. Yes or no, guys? OC plus radius of the circle. Sir, what is the OC? Sir, what is the OC? Sigma x plus sigma y by 2. Yes. Sigma plus sigma by 2 comma 0. What will be the answer? 3 sigma by 4 comma 0, right? Check it out. All of you, please check it out. 3 sigma by 4 comma 0. Perfect. What will be the values of OC plus radius? 3 sigma by 4 plus radius is what? Sigma by 4. Then what is the sigma 1? Sigma 1 equal to sigma only. Sigma 1 will be equal to sigma only. What is the minor principal stress? Sigma 2 from here to here. Check it out. OC minus OB. OC minus OB. OC minus OB. No, sorry. We need to calculate the values of OB actually. Then it will become what? OC minus what? Radius. What is the OC value? 3 sigma by 4. What is the radius? Sigma by 4. So what we are getting? Sigma by 2. And my dear friend, with your own eyes, with your just own eyes, you can see this plane is a major principal plane. This plane, minor principal plane. Why? There is no shear stress. There is no shear stress on both the planes. And by the definition of the major principal plane or the minor principal plane or the principal plane definition, on any plane when there is no shear stress, that particular plane is called principal plane. And whatever the stress will be there will become sigma 1, will become sigma 2. And the respective angles will be 90 degree. Check it out. Either you calculate by analytical or you calculate by Mohr circle, you will be calculating the same answer. Check it out. Understanding my point or not? So what is the theta 1 star and what is the theta 2 star, sir? Very simple, sir. From the reference plane, calculate the line. See, CA is a reference line and it is also one of the line that is showing the angle. See, this is a sigma 1, guys. Sigma 1 is making how much angle with the CA? 0 degree. 0 degree. How much of angle it is showing? How much angle it is showing this one, this BC, with respect to reference plane? Tell me, guys. 180 degree. Yes or no? 180. My dear friend, in the Mohr circle, angles are always represented 2 times. Theta 2 star will be 180 by 2, 90 degree. And that is what the angle. Theta 1 0, theta 2 will become 90 degree. Theta 2 star will become 90 degree. So in the Mohr circle, angles are always represented in the multipliers of the 2. No doubt. Very, very important. Now you will remember that whether the shear stress is 0 in the whole beam, in the whole member, whether the shear stress will be 0 or not. Tell me, guys. No. The plane is there, one plane is there, which is there at an angle of 90 degree or 45 degree. One plane is there at an angle of 45 degree. In the Mohr circle, it is become 90 degree, but in actual condition, it is what? 45 degree. There is a what? The shear stress of magnitude is what? Of magnitude is what? Tell me, guys, what will be the coordinate of this point? What will be the coordinate of this point? What is the coordinate of C point? C dash point. Tell me, guys. C. What is the C value from here to here? 3 sigma by 4. And what is the other value of top? What is the other value of the top? Tell me, guys, what is the radius of the circle? Sigma by 4. that represents sigma n theta and tau s theta on the plane which is just inclined 45-degree, my dear friend. This is the plane in which this is what 3 sigma by 4, and there is a one shear stress of positive value sigma by 4. Positive means what? They should able to make anti-clockwise rotation. All of you are getting my point? So this plane can we call to be principal plane? No, no, no. This is just a plane, right? And this is the plane C, C dash. This is the plane C, C dash. All of you are getting my point or not? With respect to Mohr circle, you will be getting all your answers. Check it out. Perfect. Note down, guys. Very, very important. So that's all about Mohr circle as well as principal stress and strain chapter. In the next class, we will be starting with the what? Torsional loading condition. Again, we will try to complete along with the torsional loading condition. We will try to finish one more thing. That is columns, and then we're left with the what? Then after that, we will left with only one chapter. That is one is called springs, and other is what? Pressure vessel. Right? All of you understanding? You want to solve one more problem so that you can have the idea about the Mohr circle? You want to have the discussion on the Mohr circle one more time? Before that, just note down this thing so that we can see one more problem. Done? Remember the lines. Each and every line, radial line is what? Plane. Each and every line is what? Plane. CA is what? Principal plane. Principal plane, major principal plane. BC is what? Minor principal plane. Each and every radial line is what? Plane. Remember that. Now, we will try to solve your same problem. We will try to solve the same problem with the Mohr circle, my dear friend. With the Mohr circle. Right? I think here it will be hodgepodge. So I will be just taking you to the another slide. Same problem. Just remember there is a plane. Tau direction. You just remember. Just wait. Just wait. I need to add one more slide. Now, so the same state of stress element I'm drawing. All the things we have answered what? All the things we have answered analytically. Right now, I'm going to show the same problem, same answer by the Mohr circle. Check it out. Theta, tau, tau, tau. That's it. We need to find sigma 1, sigma 2, and theta 1 star, theta 2 star. That's it. That's a very simple one. What are the coordinate? First of all, note down the coordinates for the planes. For this plane AB, again I'm taking AB, sorry, because I am representing the coordinates with the A, so I'm not writing. I'm just giving one another name, 1, 2. 1, 2 plane, and this is called 1, 3 plane. What is the coordinate for 1, 2 plane? Follow the sign convention and tell me coordinates. Coordinate means what? Sigma and tau. And follow the sign convention and let me know. First is 0. Now tell me plus tau or minus tau for 1, 2 plane. A is for 1, 2 plane. A coordinates is for 1, 2 plane. Tell me, guys. Yes, 0 tau or 0 minus tau. Follow the sign convention. Follow the sign convention which I mentioned you already. Minus, minus, minus. For this one, what will be the sign convention for B? 2 for plane, 0 and plus tau. or minus tau. Plus tau or minus tau. Both are making the clockwise rotation when you just consider 1-3 plane and 2-4 plane. But for 1-2 and 2-3-4 plane, they are making what? Anti-clockwise. So it is plus. Very good. Now you can draw the Mohr circle like this. There is a tau, there is a sigma. Draw the coordinate first of all. Coordinate A is what? Somewhere here. That is 0, minus tau. And coordinate B will be exactly the same distance, but it is in the positive one. Now what you can do, you can take the center. Center will be coinciding with the what? Origin. And you can draw the Mohr circle like this. Exactly it is symmetric, but let me try. It is going to be exactly the circle which is coinciding with the origin. Why it is coinciding with the origin? Try to find the center. Sigma x plus sigma y by 2, 0. All are 0. So center will be what? 0, 0. 0, 0. What will be my reference plane? What will be my reference plane? CA will be my reference plane. CA will be my reference plane. Let me show that. CA will be my reference plane. Means all the angle will be measured with respect to that particular reference plane. Right? Now, my friend. Now, coming to the segment sigma 1 value. Sir, what is the sigma 1? This value will be called as sigma 1. This value will be called as sigma 2. Now tell me, guys, of course, both are same. There is no doubt, both are same. Sigma 1 and sigma 2 will be directly radius of circle. Directly radius of circle. Calculate the diameter first of all. Calculate the diameter of the circle. Diameter of the circle will be what? The radius between the distance between A and B, and that you can calculate 0 minus 0 whole square plus minus tau whole square. You will be left with what? Tau. Then what about the radius? What about the radius? Tau by 2. Check it out. Sorry. It is what? 4 tau. Sorry, 2 tau. When it is 2 tau, the diameter is what? 2 tau. Yes or no, guys? When it is 2 tau, the radius will be what? Tau only. So what is sigma 1? Plus tau. Sigma 2 will be what? Minus tau. Now, once you got all these things, all the clarity, then tell me theta 1 star. From the reference plane, whatever the angle of this thing, this angle is what? CD plane. CD plane is what? Major principal plane. CE will be what? CE will be what? Minor principal plane. In the anti-clockwise direction, this angle is what? 90 degree. In actual, what will be the angle? 45. 90 by 2. In Mohr circle, it is always represented twice. What about this angle? What about this angle? Theta 2 star. 270 by 2. Yes or no, guys? In Mohr circle, it is showing 270. In actual condition, it is 135 degree. I hope, I believe things are getting clear with respect to Mohr circle. The same answer we are getting as we are, actually we were getting for the what? Analytical method. Check it out. Identifying the reference plane, identifying the coordinates are the major step for drawing the Mohr circle. Right? So that's one of the very, very important thing, guys. Whatever I'm suggesting you from the starting of this form lecture, try to stick with what I'm saying. Rest you practice like anything. That is a fundamental, principle for getting a very good rank, below 100 rank for the GATE examination on or basically what? Clearing the written examination, right? Now, once it is done, let me know. The next discussion will be happening what? In tomorrow's lecture. Little bit we'll see about the, again Mohr circle for the strain value and the shear strain and normal strain. And then again we'll just go back to what we are discussing about the columns, right? So, okay guys, thank you. Okay guys, thank you. We can leave for the day.